This is the first part of the second PowerPoint presentation of DC machines. So first we will look at the classification of DC machines. We have briefly discussed about this in my previous presentations. In this lecture I'm going to dig into all types of DC machines. Main significant advantage of DC machine is the variety of performance characteristics that can be achieved by interconnecting the field and armature windings. Now you know the field winding is providing the magnetic field inside the motor, and the armature is carrying the rotating coils or windings, right? So by providing current to these two coils in different ways, you can get different performance characteristics. So that is the advantage of DC machines. The excitation, that means the magnetic field, the creation of magnetic field inside the machine is called excitation. The excitation for establishing the required field can be of two types. One is electromagnetic excitation, the other one is permanent magnet excitation. That means that the magnetic field can be produced by permanent magnets or by using electromagnets. So let's first look at the electromagnetic excitation. So electromagnetic excitation is widely or universally used, even though external energy is required to establish the field, because you have to supply current to the field coils. It has the advantage of being less expensive and easy to control. So by using the supply energy to the field coils, by controlling that energy, you can control the characteristic of the machine. So that is why it is widely used, because it is easy to control. The field windings can be excited by a separate DC source, which is connected only to the field windings and not connected to the armature. That means you can connect the field windings to a external separate supply, which is independent from the armature coil. So such configuration is known as separately excited DC machine. Okay. So alternatively, the field current can be all or part of the armature current. That means the field coil and the armature coil are interconnected, so that part of the armature current or full current is also going through the field windings. That means it can be like same supply, or maybe even different supply, but there is a relationship between the armature current and the field current. Then it is known as self-excited DC machine. So let's first look at the self-excited DC machines. The separately excited DC machines. In the separately excited DC machine, the field windings are supplied from a separate DC source. The advantage of this type of excitation is that the field is not affected by any changes in the load, right? That means, maybe say for example, if it is a generator, load means the external circuit that we connect to the current generated. If it is a motor, the load means the mechanical load that we try to rotate using the motor. So when the load is changing, the current through the armature coil is changing, right? But in the case of separately excited DC machines, the advantage is uh, the field coil current is not dependent on the load. That means it is independent, right? In the case of high voltage machines, the field can be supplied from a low voltage source, making it easier to control, and it is safer for operation. So that is the main advantage of separately excited DC machines, which is it is independent from the armature current or the load. Then we look at the self-excited DC machines briefly. When we say self-excited, there are three different types of self-excited DC machines. These types you have to remember because there could be some theoretical questions on the exam. So therefore you have to understand and remember these theory parts as well. So what are these three types of self-excited DC machines? First one, series self-excited DC machine, in which case the field windings are connected in series with the armature. The field winding is connected in series with the armature winding, so the same current will go through the armature and also the field winding. So if you look at this diagram, let me enlarge it a little bit. This is the motor, right? These are the armature windings, 4 brushes shown here, and how they are interconnected is shown here, and also the field windings. Here you will see the field winding, and this armature winding is indicated with A1 and A2. Field windings S1 and S2, right? So to see the interconnection of these coils, we can use this diagram. You will see the positive power supply is given to the armature, so it is going through the armature and coming out from A2 here, and then that is connected to the field coil in series. So the current will go through this path and then again on this one, and then coming out as the negative terminal of S2, right? So these two coils are provided with the same current like this. See, A1 and A2, S1 and S2 are seriously connected, right? So this is what we call the series self-excited DC machine. So let's see the characteristic of this configuration. The full armature current flows through the armature and field windings. The coils in the series field are made of few turns. Normally the coil in the field winding field windings are made of few turns. That means quite few number when you compare it with the armature coil. Of large gauge, that means the size of the wire should be, the diameter of the wire should be very large to facilitate large current flow, because the same current that is going through the armature is going through the field winding as well. Armature current is normally large based on the load. So even though you have a small number of turns on the field winding, the current is large, so it will produce enough magnetic field for the rotation of the armature. Series DC motor armatures are usually lap wound. I hope you remember we talk about lap winding and wave winding. So these series self-excited DC machines are normally lap wound. So the advantage of lap winding is that it can carry high current with low voltage, right? So in the case of lap winding, we can have large number of parallel paths, right? I hope you remember in case of lap winding, the number of parallel path will be equal to the number of poles, right? But in the case of wave winding, we have only two parallel paths, right? It is independent from the number of poles. So lap winding is good for large currents, and wave winding is good for large voltages, right? So here in the series self-excited DC machine, we are using lap winding. Right now, let's look at the other type. It is called shunt self-excited DC machine. So as the name implies, you can easily remember the two coils, armature coil and the field coil, are in parallel. The field windings are connected in parallel with the armature. So if you look at this diagram, you see now the field winding is given plus and minus. At the same time, S1 and F1 and F2, the field windings, are also getting the parallel connection from the same DC source. So the currents going through these two, the field winding and the armature winding, is again dependent because it is provided with the same DC voltage supply. So depending on the impedance that is seen by the supply from armature and field, the current will be divided among them, right? So so they are again dependent, right? So this is how the shunt self-excited DC machine coils are connected. So now let's look at the main features of the shunt self-excited DC machine. Shunt motor is probably the most common DC motor used in industry today. The coils in the shunt field are composed of many turns of small wire. The field coil, not like in the series case, we have many turns and the wire size is smaller because the current will be smaller, resulting low shunt field current and moderate armature current. Right. So in addition to the series and shunt self-excited DC machines, we have one more. It is called the compound self-excited DC machine. When we say compound, that should be a combination of series and shunt. So a compound DC motor has the field connected in both series and shunt with the armature. That is, the field winding is a combination of the series field S1 and the shunt field F1, right? The series field is connected in series with the armature and both have the same current. The shunt is connected in parallel with the series field and armature combination and may be powered by a separate source. So that means this is a combination of series and shunt self-excited machines. So if you look at how they are connected, uh, see, this is the armature winding, and this field winding is connected in series with that, and then coming out here in the negative terminal, right? Sorry. And then the other winding, that is this one, which is parallel to these two windings, like this, right? So this is what we call the compound self-excited DC machine. Again, there are two types. One is called uh, cumulative or cumulative compound, and differentially or differential compound. So that means the compound motors can be connected in two ways. One is commutatively and the other one is differentially. If it is connected commutatively, we call cumulatively, then we call it cumulative compound. And if it is connected differentially, then we call it differential compound. So in a cumulative compound, the series field is connected to aid the shunt field. So that means they are like adding together. They are the series field is connected to aid the shunt field. That means the magnetic field created by the series field coil and the shunt field coil are adding together, then they are called cumulative compound. And if the two fields are opposing each other, so that the resultant field is less than the the resulting field is reducing, then it is called differential compound. In the cumulative compound, fields are adding. In differential compound, fields are opposing, right? So if you look at the diagrams here for the cumulative compound, the way that coil is wound for the field winding is actually adding the field created by the shunt field coil, right? So in that case, say for example S1 and S2 here, it is connected to S2 is connected to F2, and S1 is through the armature connected to F1. So this is called cumulative compound, right? So the two fields created by this one and this one are adding together. And then if you look at differential compound machine, this coil connection is interchange, like S2 is going like this, and S1 is connected to F2. If you compare these two, here it is S2 S1, in the cumulative it was S1 S2. So so this is called differential compound. So these are the types of DC machines we have. So if we look at these compound self-excited DC machines, differentially connected compound motors are sometimes referred to as suicide motors. This is a special note on the differential compound self-excited DC machines. The reason is their tendency to self-destruction. Let's see how it is happening. If the shunt circuit were to suddenly open, if the shunt circuit is suddenly open due to some reason, during loading, right, the series field would then assume control. So because then only the series field is working. I'm talking about the differentially compound, that means the two fields are in the opposite direction. So now one field coil is gone, then what will happen? Only the series field coil is active, which is opposite to the field of the um, mm, shunt field coil. So the resultant magnetic field would reverse, right? So this results in the motor stopping because it is rotating in the other direction. So now you get a different direction of the field, therefore it will first stop and then restarting in the opposite direction, then you start to rotate in the opposite direction. It then operates as an unloaded series motor because the load was on the other direction, but now it is rotating in the direction of the load. So it is like unloaded series motor. So unloaded series motors, we earlier said that where the armature current will be very large and therefore it will destroy itself. So differential compound motors can also start in the opposite direction if the load is too heavy. The other problem is if the load is very heavy, then armature current is larger, therefore the series winding, the field will be larger than the shunt field winding magnetic field, therefore it will rotate in the opposite direction. So due to these reasons, this differential compound self-excited DC machines are not used or rarely used in the industry. And again, these differential compound, compound self-excited DC machines have two other variations according to the way they are connected. I mean the series field and the shunt field. They are called short shunt and long shunt. If the shunt winding is connected across the armature, it is known as the short shunt. That means the shunt field is only parallel with the armature coil, not with this one, right? If you connect it like this so that the shunt winding is parallel to both these two, then it is called the long shunt machine. It says alternatively the shunt winding can be connected across the series connection of the armature and series winding. So in this case the machine is known as long shunt machine. Right. So that is about the separately excited and self-excited DC machines. Uh, in both the cases, we have to give supply to the field winding. But you might have seen that there are certain DC machines, especially the smaller ones that you can see in the lab and in most of your toys, are not having any field windings. Instead of the field winding, it has a permanent magnet in place, right? So those are also considered under self-excited DC machines, sorry, separately excited DC machine, uh, because the field is independent from the armature current. So let's look at them. This is called permanent magnetic excitation. The field excitation is provided by a permanent magnet, PM. This type of machine is also classified as separately excited machine since the armature current is independent of the field current. So, there is no field coil. It is only a permanent magnet, and you can give only the current only the armature with the external current. So this is this is the kind of motors that you can see, DC motors or DC machines in the lab, right? Uh, so it is connected like this. So that means you don't have to give supply to the to generate the magnetic field. Let's see what are the characteristic of this type of DC machines. Permanent magnet excitation was that is basically a sorry, this should be wrong. This should be corrected as separately excited. Let me correct it now itself. They are not self-excited, they are separately excited. Separately excited, yes. Right. So permanent magnet excitation is employed only in extremely small machines where it becomes infeasible to provide field coils. So in small machines, the space is very small, therefore we can't have a space for the field coils. Also, permanent magnet excited field cannot be varied for control purposes. Even it is permanent magnet, then you can't change the strength of the field. Permanent magnets for large machines are either not available or too expensive because making stronger permanent magnets is very expensive, and sometimes there is a limit that you can go. You can't go beyond that strength if you are using permanent magnets, and the size also might be bigger if you use high power permanent magnets. However, an advantage of permanent magnet excitation is uh, there are no losses associated with the establishment of the field. That means it is not consuming any energy to generate the magnetic field. So, so in this short lecture, I introduced the several types of DC machines. There we said that mainly there are two types. One is separately excited DC machines. The other one is self excited DC machines. Uh, so they both are coming under electromagnetic excitation. But the last type that I discussed was about the permanent magnet excitation. Normally it is considered as a separately excited DC machines. So under electromagnetic excitation, we said that there are two types: separately excited and self-excited. And the separately excited DC machines, there are no other variations. It is like field coil is supplied with a separate supply, and armature coil is supplied with separate supply, right? So the advantage here is you can control the characteristic of the motor by changing the supply to the field winding, and as they are independent, the field is not changing according to the load, right? That the advantage is that the field is not affected by the changes in the load. And then we said that there are two types of self-excited DC machines. One is series self-excited DC machines, where the two coils are connected in series, and then the other one is called the mm, shunt excited DC machine, where the two coils are in parallel. Uh, so and then we we have another type which is called compound self-excited DC machines, where you have one coil in series with the armature, the other coil in parallel with the armature. And then we said there are two types of the compound machines. One is called the differential compound, and the other one is called the cumulative compound. According to the way the resultant magnetic field is generated, whether they are adding up together is called cumulative, whether they are opposing each other they are called differential compound. And we said differential compound machines are not very much used in the industry because they are suicide type motors, like self-destructive. And then again the compound self-excited DC machines, we have two types called short shunt and long shunt, according to the way they are connected. Short shunt means the field coil is just parallel only with the armature coil, and long shunt means this shunt is parallel to both the armature winding and the series field winding. Though finally we talk about the permanent magnetic excitation, but the disadvantage of the permanent magnetic excitation is we can't control the magnetic field like in the excited field windings. And also this method can only be used with smaller machines, because for larger machines we can't find high I mean powerful magnets. Even if you produce powerful magnets, it will be expensive and also will be large in size, so it is not feasible. Therefore the permanent magnet excitation is mainly used for smaller DC machines. So you have to remember these types. uh, so in my next lecture I will discuss more about these DC machines. Thank you very much.